Teatown wants to learn about the same subjects, the same topics that the students have done their projects on. Invasive plants, watershed pollutants, wildlife. They aid us in the management of our preserve, day in and day out. So I really want to thank, first and foremost, I want to thank Danielle and Mike as the mentors and the teachers of this course, because the mentorship that they provide the students is really paramount. It's the most important thing of all. And for many of the students, it's their first science research experience. And this symposium tonight is kind of the culmination of that whole experience. So we welcome you all here. We thank you. And with that, I'm going to hand it over to Dr. Danielle, and we'll be off to the symposium.
So why should you care? Well, a man named Leopold Triviolet first brought these gypsy moth eggs from Europe in 1869 when he was doing research in America. So this makes them an invasive species. Like any good present, he lost it, and they escaped his backyard. By the late 1880s, serious defoliation was being caused. Defoliated trees use their energy to replace their leaves rather than to complete photosynthesis, so they don't have enough food, which makes them weak. This weakness makes them more susceptible to diseases, environmental stresses such as drought, reduced rates of growth, and it also provides them with second growth leaves, which disrupts nutrient cycling because they're more durable. This is the scientific name for the gypsy moth caterpillar. They're about 2 inches in size, and you can find them mostly during May and June. So despite their size, they have the potential to wipe out forests at a time. Trees could also fall over due to weakness, which creates unwanted obstacles on roadways and on private properties such as homes and buildings. Repeated defoliation can kill a tree, and that leads to reduced oxygen, disruption of food chains, and loss of food and habitat for animals. In addition, no forest means you can't have any timber harvesting, which is a really big part of our economy these days. It exceeds $20 billion US, and it also provides for paper products, furniture, and house framing. So a question I had while researching this was, does human disturbance affect these caterpillars? Because that hasn't been studied yet, so I was waiting to see what the results would be. A virus commonly associated with these caterpillars is the baculovirus, also known as the zombie virus. And basically what happens is a caterpillar feeds on the leaves of an infected tree, and basically those leaves are infected with the virus particles from a previous caterpillar, and then that stops them from the molting phase, and they're continuously feeding and eating, developing more of these virus particles. And then the virus hypnotizes them into going into a position on the tree where they can enhance transmission to new hosts, and then they explode and die, and then the remains of their bodies melt, and those virus particles then drop onto foliage below, and the cycle repeats as a new caterpillar then eats those leaves. So the virus is related to their DNA, so it has come with them from Europe, so it has nothing to do with America or Europe individually, but rather the DNA of these caterpillars. So my research question is, of the trees infected with this virus, do the numbers of dead caterpillars correlate with caterpillar host preference and or human use patterns? So my 2 hypotheses were, if the host is preferred by the caterpillar, then there's going to be a greater number of dead gypsy moth caterpillars on that tree. And if the host is in an area of lower human disturbance, then there's going to be a greater number of dead gypsy moth caterpillars on that tree. And the way I was going to be observing this is, once a gypsy moth caterpillar dies on the tree, it remains on that tree for a period of time, and it hangs in an inverted V position, and it changes its color from white to black. So it's pretty obvious when you can tell that they have the virus and they've died. So I think these hypotheses to be true because typically when a host is preferred by a certain insect, that insect is going to be found on that host, and also living organisms tend to fray from human disturbances because they don't want their homes to get destroyed and they don't want to deal with pollution. So by figuring out these host preferences, we can understand other potential hosts to monitor for gypsy moth damage and then potentially take steps to control them. So this is an observational study, and I chose 3 levels of preferability for these caterpillars. The first was favored, the second was unfavored, and the third was avoided. So for each level of preferability, I chose a species of the tree, and I decided that I wanted to do at least 12 of each tree in each of the sites I was going to be researching. So my variables are the human disturbance in the area, either high or low, the tree species and level of preferability, which are the 3 I just previously mentioned, the surface area of the tree, as well as the distance from caterpillars to the ground, so basically where they are on the tree. So these are the 4 sites I chose. 2 of them are high disturbance for humans, and 2 of them are low disturbance. So my methods were that I walked through the 4 trails, and I identified this tree species through their bark and through their leaves. Then I counted for the caterpillars by taking a 360 view of the tree, and then if I needed to, I'd look higher with binoculars. I also measured the diameter of the tree using a DBH tape, which basically is translated to diameter at breast height, and I standardized the counts of the trees measured because I didn't want any trees that were lower than 4 inches so that I didn't have any weak trees that tampered with the data. So my results. So these are the prevalence infection rates. So for oak trees, there was a 75% rate. That's you. So there were 44 out of 59 trees infected. For American beech trees, these were the non-favored trees, there was a 50% chance rate, and 30 out of 59 trees were infected. And then for the last category, yellow poplar trees, also known as tulip trees, that was the avoided category, and there was only a 2% rate. So this basically fit with what I thought was going to happen, that there's mostly more trees infected with the favorite trees. So my susceptibility results were kind of different. Out of the 162 trees tested, there were 792 caterpillars found. In high disturbance, there were 629 found, and in low disturbance, there were 163, which contradicted my hypothesis because I thought there was going to be more in low disturbance. In addition, there were more caterpillars on American beech trees, which were non-favored, than oak trees and yellow poplar trees combined. So there were less caterpillars overall on favored trees, yet more trees were infected over time. So I wanted to see what the interactions were between the preference host status and human disturbance levels. So here you can see I have the 3 preference statuses: avoided trees, favorite trees, and non-favorite trees. And along here, I just have the average number of caterpillars per 1 inch DBH, which is basically the diameter. So the only statistically significant difference was with non-favored American beech trees at high disturbance, which I labeled B. And you can see all the other 5 points are labeled A because there isn't too much of a difference. All the numbers are mostly the same. And the lines here show the error bars that may have been resulted as human error for not accounting for all the caterpillars, etc. In addition, I wanted to see, the literature always tells us that the caterpillars climb to the canopy of the tree when they die. But when I was looking around the forest, I saw that not all the caterpillars were at the top. In fact, there were some caterpillars that were only 2 inches off the ground. So I wanted to see if the caterpillar density on the tree had any correlation with the distance to the ground. So when I did see that, here you have the distance from the lowest dead caterpillar to the ground, and here you have the mean average per 1 inch DBH, which is also diameter. So though it's statistically significant, this line only represents 5% of the data, as you can see by the R² value. So it isn't too much of a big deal, but also, if you can see over there, it says canopy, and that's over 84 inches. So only those points are the ones that the caterpillars actually reach the canopy. All the other points are the caterpillars that have not reached the canopy, so something's not letting them get all the way up there. Maybe it's the virus is too strong for them, and they start dying before they get to the top. So while walking through the forest, I observed other live stages of the caterpillars. So here was an egg mass that a female gypsy moth laid, and I also saw 2 live caterpillars. One was crawling up the tree that you can see over there, and then one was walking on barbed wire. I feel like this one would have been infected because of the way it was walking to the top of the tree. And these caterpillars aren't typically supposed to walk in the daylight. They prefer nighttime so they don't get eaten by predators. In addition, I saw caterpillars that were on leaves, rocks, and barbed wire. So perhaps the virus particles dripped further off the tree and maybe on plants surrounding it, or the caterpillars just didn't make it all the way to the tree and they fell off, which provides some error in the future. The discussion. These are my 2 previous hypotheses, and to prove whether they were true or not, I observed these things. So there were a greater number of oak trees infected, which were the favored trees, yet there were a greater number of caterpillars on American beech trees, which were non-favored, than favored and avoided combined. So this hypothesis was false. In addition to my second hypothesis, there were higher number of caterpillars in high disturbance areas rather than low disturbance areas. But I also had to keep in mind that in low disturbance areas, there were vines on the trees which deducted some of the surface area, so the caterpillars may not have had enough space to climb to the top. So both of my hypotheses were false. So I concluded that maybe it isn't just about the type of the tree, like the species, but also about the shape of the tree. Because I saw a lot of caterpillars on trees that had lower branches, which is why American beech had a lot. And I also did not see too many caterpillars on trees with vines because that covered the tree. So maybe a possibility for this could be that the caterpillars had to travel less to get to the lower branches and eat those leaves. I also concluded that higher disturbance areas created more stress on the trees, and that therefore weakens the trees and makes them more susceptible to caterpillar damage. Some sources of error could be that I didn't account for all the caterpillars, for example, the ones that were on barbed wire or rocks that fallen off the tree. And I also didn't see caterpillars that might have been hiding behind branches or intertwining trees. In addition, I also didn't find any yellow poplar trees in one of my trails, so that could have tampered with some of the data. Future studies could be to test whether these infected caterpillars would rather choose oak trees or beech trees, because there's something about these beech trees that was attracting these caterpillars, and I wanted to see what it was. In addition, I could create an artificial structure with DBH, height, species, all of that as a control, and then just keep a variable as to different positions of branch heights to see if the caterpillars really have a preference in that kind of structure. So I'd like to take this moment to thank my mentors, Dr. Danielle Begley-Miller, Dr. Michael Rubo, all the TESA students, Teatown and the TESA program for allowing me to be here, and my parents for their support. Any questions?
So I'm happy to introduce our next speaker, Dominic Polycarpou, who's a rising senior at Sleepy Hollow High School, who's going to be talking to us about styrofoam biodegradation, comparing the capabilities of mealworms, woodlice, and millipedes. Take it away, Dominic.
Okay, so styrofoam is a major global problem, as some of you may know. It is difficult to degrade, not recyclable, and it is a mild carcinogen. It also moves up the food chain. This means that removing as much from our environment as possible is a pretty important thing. As you can see here, it also is not present in any small numbers. It is a pretty large problem. So, what current methods of degradation do we have? Currently, degradation uses a lot of time, heat, or harsh chemicals. So this is the styrene molecule right here. You see that is the aromatic ring, meaning it's very stable and difficult to break down. This means that it requires a lot of UV light from the sun over many millennia, a lot of heat and energy in an incinerator, which also releases some dust into the air, or some harsh chemicals that mean that require industrial processes. None of these, as you can see, are pretty viable options for actually breaking it down, and none of them are really a long-term solution. So some people have turned to biodegradation as a solution, using natural methods. So these are currently our two methods for doing so. Certain fungi and mealworms are essentially it. However, these are both limited in scope and potential. Certain fungi with Fenton's reagent require some industrial processes and are also not able to break it down fully. Mealworms actually don't break it down fully and leave some microplastics behind. So as you can see, this is a little mealworm, and this is Fenton's reagent. However, from my prior research, I did feed polystyrene to mealworms, degraded by 20% over 2 weeks, which is pretty significant considering that it was eaten and not broken down. It was actually consumed as an energy source. However, this research is very new. The article that led me to this field was published in 2015, meaning this entire field is completely brand new. There's really no research on this topic. So these are just some pictures from my prior experiment. So, some other things. This is a new field of research. Other organisms may have biodegradative abilities. We don't really know because really very few animals have actually been tested like this. Some local organisms may be useful, and I wanted to see what other organisms just in this very area could actually do this because we currently don't know. So, woodlice, Onissidae, are able to eat polyethylene starch mixes, and other research suggests that bugs that are able to eat polyethylene might have abilities to degrade polystyrene. So I wanted to test to see if they had that capability. And greenhouse millipedes are very common decomposers around here, and they also are common pests. So it might be useful to know if they have this ability because they are very abundant. They also might not. This is a greenhouse millipede, and these are pictures of some woodlice. So, my hypothesis is, if greenhouse millipedes and common woodlice can biodegrade polystyrene, then the weight of the polystyrene will decrease over time, comparable to the mealworm biodegradation. So, first the method I had 6 trial groups, mealworm, millipede, and woodlice, which then split into control and polystyrene for each. This was also then repeated 3 times. So, my containers were 34 by 21 by 12 centimeter plastic containers with bedding of leaf litter and dirt. They had polystyrene chunks placed on the surface. They were given apples every 3 days because they require apples for nutrition and also water. If you feed them just water in like a plate, they actually drown themselves. So it's important to give them other sources. They're also misted every day because woodlice and millipedes prefer a wetter environment. They live under logs and such. So if they were dried out, that would not be good for them. They were kept in a semi-dark room to more mimic their natural environment. So an average pH was kept at about 7.3 with standard deviation of 0.312. So that's a picture of the room they're kept in. You see the little tubs, and this is some polystyrene. There's some dirt at the bottom, and this is leaf litter. So every day I would weigh the polystyrene after gathering the containers, and then every 3 days I would count and weigh the organisms. I'd not weigh the organisms every 3 days, every day, because it requires you to extract them, and that's pretty traumatizing for them. It actually harms them to do that too often, so you want to limit that as much as possible. So here's a graph of the mealworm weight change. As you can see, it actually decreases over time. So the polystyrene trial, which is the green line right there, started smaller, but also didn't actually change much significantly. It didn't start smaller and then get dramatically smaller or get dramatically larger. It stayed about the same difference as the normal. So as the group did not diverge, the mealworms did trend downwards, and this is reasonably significant because mealworms are larvae. They actually grow into the darkling beetle. This means that they should be constantly growing. And if they're decreasing in weight, that indicates they're doing poorly in some respect. For example, if you had any sort of young whatever and it kept decreasing in weight over 2 years, you would say that's not great. So the millipede, as you can see, the millipedes, they diverged, but not really, especially when you consider that this weight in grams is very small amounts. So that is easily due to the scanner being, the scale being slightly off, them being slightly wet that day, something like that. So there's not really any significant variance between the polystyrene and the control. And this is also not an indicator of health because these millipedes are full grown. So they shouldn't be changing in weight very much at all. The woodlice, as you can see, it changed slightly, but there's not really any significant variance, again, because this is very small amounts of weight, and they also had a small sample size, meaning that anything drawn from this is somewhat unreliable. So the mealworms, this is a graph of mealworm mortality. So you see it goes down a small amount. Mortality is similar in both groups. As you can see, they ended up about the same place. Some death is expected. Unfortunately, once you take bugs into captivity, they don't deal well for a variety of reasons. So this is somewhat expected. Millipede mortality, this actually is 2 lines. However, they're overlaid because the mortality was exactly the same. But some millipedes did disappear, which is also expected. There's something they eat each other, whatever. Yeah, so this is woodlice mortality. Again, it has similar mortality, not significantly different, especially because there's a very small number of woodlice. However, most woodlice did survive, which is good for them. So here's the important graph, the polystyrene weight change. So as you can see, it increased in weight pretty significantly. So this indicates that it is not being degraded. So there are a couple factors might be attributed to this. So there is some variance due to water misting. Groups are generally similar. However, there is no indication of degradation, and this indicates that the mealworms, for whatever reason, were not eating it. As you can see, the divergence doesn't actually diverge. The mealworms actually are, yeah, the mealworms don't actually change the polystyrene very much. The p-value for this is something like 0.84, indicating there's like an 84% chance this is completely random chance. And there's no negative weight change at all. So even if this were a method of degradation, it wouldn't be very helpful to us. So some just basic things to discuss. The mealworms decrease instead of increasing in weight, indicating this is probably not very healthy for them due to excess water from the misting. It also might be that they don't like the food quite as much. The polystyrene was not shown to be degraded, which is interesting as it ties into the fact that it might be that if the mealworms are slightly unhealthy or in a different environment than the pretty tightly controlled one that I kept them before, they're kept in an incubator at a very specific temperature with light cycles and so on. If they're not kept in a specific scenario and they're not able to degrade polystyrene, that indicates they might not actually be as helpful as previous studies have suggested. The millipedes were aware of the polystyrene. They actually crawled over it and they left some fecal matter on it. So they actually did crawl over it, but they decided not to eat it. And there were small number of woodlice results unreliable. However, they also didn't appear to eat it either. So, some sources of error, where there are some small sample sizes. Scale used to weigh the polystyrene may be somewhat inaccurate. There's a short experiment time. and the missing changes the weight of the polystyrene uncontrolled variable. However, also dirt and leaf litter adhere to the polystyrene a bit when putting them in and taking them out. So, however, here's a conclusion. Millipedes and woodlice do not degrade polystyrene, indicating they don't have this ability. Mealworms do not degrade polystyrene, different from prior research, which suggests that degradation might be limited by a different habitat. And the mealworms are limited in degradative capabilities beyond what actually all previous studies have said. So, I like to test in the future the effect of the environment on mealworm degradation, test other secondary decomposers, and test mealworms in compact mesocosms to see if they're compacted in more dense environments, if that affects it. For acknowledgements, I'd like to thank Dr. Bailey Miller and Dr. Rubo, my science research teachers, tested students, and my family. Thank you.
It's my pleasure to introduce Christian Kirchmann, who is you're a rising junior, going into junior at Somers High School, who's going to be talking to us about breeding site preferences of mosquitoes, how pH affects mosquito larvae and eggs.
Okay, so I'll drop a scenario for you. So you're at, a beach, you're cooking burgers, then you hear it. It's a mosquito. Instantly, you're upset. Mosquitoes are annoying. So mosquitoes are also, more than annoying because they could carry deadly diseases. So there's actually a lot of interaction between mosquitoes and humans, which, causes a lot of issues for us mainly. But there are some issues that fall back onto mosquitoes, such as pollution. So with people polluting the earth, acid rain is happening. And acid rain is essentially the rain being more acidic than usual. And this leads to more acidic lakes and rivers because the rainwater goes into these water bodies and therefore affects them. So I wanted to see how mosquitoes would, choose where they lay their eggs based off of pH. For example, could a mosquito tell if water is acidic or neutral? And I wanted to see that by laying out different pHs of water in mesocosms of 5, 7, and 9. 5 being acidic, 7 being neutral, and 9 being basic. And I believe that the mosquitoes would prefer the pH of 7 as it is neutral and it is the most common pH for most bodies of water. And for my second experiment, wanted to see how mosquito larvae themselves would develop in mesocosms, as mosquitoes, similar to frogs, first undergo life as aquatic, then they become more land-based, and by that they fly around. So I wanted to test how mosquito larvae would develop into adults. Now I tested that with, again, a pH of 5, 7, and 9, and so for my first experiment, like I said, wanted to change the pH of the water and let mosquitoes and essentially nature just do its thing and see what would happen. So I adjusted the pH by using sulfuric acid and sodium hydroxide. And I wanted to see, like I've been saying, how many eggs would be laid in each mesocosm. This does have its errors though, because mosquitoes could randomly just prefer one mesocosm over the other just because of randomness. And so I set it up by using my distilled water, which has a pH of 7, meaning it's neutral. And I essentially put them outside over there. And like I said, I wanted to let mosquitoes do their thing. I would count the eggs every day. And I would adjust the pH every other day to make sure that the pH was the same, because water would evaporate and the pH would constantly change. And there were some issues with this, which I will talk about later. However, for experiment 1, I didn't get any data. No mosquitoes decided to lay their eggs. So I got bit by some, but yeah. So I believe that this is because there's no organic matter. If you notice where a lot of mosquitoes lay their eggs, there's algae and other, life forms, where in this, there were no other life forms in general, so that might be a reason. I also noticed there were some buckets outside, and they had like some dirt and grass in them, yet they had a lot of mosquitoes. So, yeah. So for experiment 2, the one that succeeded, I essentially did the same thing. I put distilled water in different mesocosms, as you can see here. I would then adjust the pH of these mesocosms, again using sulfuric acid and sodium hydroxide. And I would put 15 different mosquitoes in each of the different mesocosms. So this would allow me to determine how many would make it to adulthood. And I would use that by using the mosquito emergence trap. So it's essentially a lobster trap for mosquitoes. Once they developed from here into adults, they would fly out and they wouldn't be able to go back in. So that would provide me with an easy way to count them. And yeah. Okay, so I already talked about this, but I essentially used distilled water again, which has a pH of 7. And they would then adjust it using sodium hydroxide and sulfuric acid. And I created 4 replicants of this, meaning there are essentially 4 of them. And I counted the mosquito population every day, and I would measure the water qualities of the mosquitoes, the mosquito water every other day, such as DO. Some other factors were the algal growth and the water conductivity, as well as the pH. So for my results, it was actually good. I found that mosquitoes were more likely to survive with a pH of 7. This is most likely because of the fact, like I said earlier, most water has a pH of 7. And it is also neutral, and acid, tends to harm a lot of life, and basic things do not. Neutral things do not. However, there are some things that do need to be fixed with this. For example, the pH kind of, went rogue and did its own thing. I also would like to test more mosquitoes because I had a relatively small sample size due to the fact that it was hard to find mosquito larvae. So as you can see here, with the mosquitoes that developed in a pH value of 7, they were much more likely to survive towards adulthood versus the graphs that show the pH values of 5 and the pH values of 9. So 7 is clearly the winner, and it is neutral. And as you can see from this graph here, a lot of mosquitoes would develop daily from the pH of 7, because this graph shows the length in which their mosquitoes became adults, and it shows the essentially the average amount of mosquitoes that would hatch every day. And as you can see, the time frame for when the mosquitoes would develop into adults was much longer for the pH of 7 than it was for the pH of 5 and pH of 9. So I talked about this earlier, but the water quality was an important issue concerning the mosquitoes. And one thing was the pH, and I did not take into account how much it would change. As you can see from this graph, within 3 days, my pH went from 5 to over 7, which was a big issue. So I would have to adjust the pH every other day. I elected not to adjust it every day due to the fact that adjusting the pH required me stirring up the mosquito container itself. And I wanted to avoid, interfering with them as much as possible. So I chose to do it every other day. And as you can see, a lot of the water trends to somewhat go towards like a pH of around 8 for some reason. The pH of 7 rose, and the pH of 9 decreased, and the pH of 5 increased. So I would like to use, so the optimal pH, like I said, was 7. They're better suited because it's neutral. And, whether we want to admit it or not, mosquitoes are technically important for the ecosystem of many places. They feed things such as dragonflies, which then feed frogs. So the food webs would be messed up without mosquitoes. Even though they are a pain, we do have to live with them. It also shows another aspect of how people harm the environment, which is acid rain, which I discussed earlier, but it does highlight how much our impact does have on the wildlife itself. And for my future research, I would like to test more extreme pHs, being 4 and a pH of 10. This is because I wanted to see if this experiment was like a fluke, so to say, and to determine what pH is the best, to see if mosquitoes actually can survive in a low pH such as 4 or 10. And I would like to also use more mosquito larvae this time, because I did not have access to a lot of mosquito larvae, as I had to get it myself, which was a hard process and was very annoying. So I'd like to thank Dr. Rubo, Dr. Begley Miller, my family, and the TESA members. Are there any questions? Yes.
Did you test the pH in the bucket where the mosquitoes were growing naturally?
Yeah, and I had to adjust it, which took even longer, so it was real pain.
But what was it when you tested it?
I believe it was similar. I believe most of the pH is just drifted by like a factor of 1.
No, she means the white buckets.
Oh,
where we saw them.
Oh, those
breathing.
white buckets?
Yeah,
oh
did
no.
we test that?
I don't think we did.
I'm at the bucket where
Yeah,
you
that's a
said,
good
you know,
question.
you
They're
didn't
still
have
out there, so we can
mosquitoes,
check
but-
that.
Oh yeah.
Yep,
Oh,
they're
that
still out there,
bucket.
so we can,
Oh.
yeah, we should do that. We'll do that tomorrow. That's a good question.
So you actually got the larvae or the eggs?
I collected the larvae, which then became mosquitoes. I wanted the eggs to be there from mosquitoes themselves naturally. So to get the larvae, I had to, go to like the lakes around here and find certain water because they're very picky about where they like to live.
Questions? All right, thanks, Christian. Thank you so much.
Thank you.
All right.
So next
here
up
go.
we have Alicia Mateo. She is from Palisade Preparatory School in Yonkers, and her project is the effective invasive and native plant status on deer browsing preference.
Okay. So why is this important? So studies show that overabundant deer are an environmental issue because they limit biodiversity in forest. There's a lot of deer eating a lot of things, and most of the plants that they eat are very similar. So they're eating similar plants, less variety in the forest. They disrupt other wildlife habitats. So there's too many deer. They're destroying the structure of the forest. They spread ticks and zoonotic diseases. Zoonotic disease is a disease that happens from the transportation of diseases from animals to humans. So that's pretty deadly for us. And they cause frequent motor vehicles accidents, which is a risk to everybody who comes to Teatown. So deer browsing preference can help us better understand deer habitat use and changes in plant amount in response to overabundant deer populations. So how much has the plants been reduced by all this overpopulation of deer? So my question is essentially, what type of species of plants do deer prefer to browse? If the status of invasive or native alters the deer preference. So native species of plants are plants that are native to the United States, relation to their name. But invasives are from other countries who are harmful to insects, other wildlife, and native plants here in Teatown. So my hypothesis is that because of evolution and how plants and deers and animals have co-evolved together, then the deer are going to prefer to eat the native plants instead of the invasives, because of chemical recognition. Because all this time they have co-evolved together, so the deer are more likely to recognize the native plants because of the chemical recognition. So to support my hypotheses, studies show that jewelweed, which is a native, is more likely to get browsed on instead of garlic mustard, which is an invasive. So my design is experimental. So I manipulated plants. So I brought them to my sites and to test the deer preference for browsing. How I did this, I transported 8 different plants, 4 native and 4 invasives to keep it equal. And I transported them in buckets to 3 different locations and took a video at each location to track the browsing. Each video was around 2 minutes. So as you can see here, these are my sites. So site 1 was near Cliffdale Loop, site 2 was near Hilltop, and site 3 was near Hidden Valley Loop. So this is a picture of the buckets and the plants that I collected and transplanted in these buckets. And these buckets were ideal for this experiment because I wanted to elevate the plants to the ideal height that deer like to eat, since they don't like to be crouched down when they're eating. And this is a picture of where I had the plants and where I transported all the plants to from here, the Science Center, to all 3 sites of mine. This is the camera I used at all my sites. And this is a picture. You can see the water bottles here in the corner. And those are 8-ounce water bottles that I used every time I went to water my plants, which was 4 times within the week that I was conducting my research, which was July 11th, 15th, 16th, and 22nd. So, video results. Give me a second to... See if I can make it. There we go. You see this? That's a possum. I know he ran away quickly. And that's a baby coyote. He seems to be very interested in the camera. And a raccoon. And here, this is a very interesting part of the video, because you see he's sniffing and he gets really close to my plants. Did you notice anything missing? Any guesses of what was missing? Deer. You are correct. There was no deer. So I had no deer at any of my sites, unfortunately. But what we do know is that it wasn't due to my plants. In this graph, you can see that my native and invasive species of plants were both at the same height throughout the start and end of me conducting my research. Same thing goes with my width. And this is important because this supports my statement that it wasn't because of my plants. My plants were available to the deer at all times from beginning to end of my research. My project was dependent on deer, which limited my results, as you could see. And another thing we saw is that there were some predators in the video. So the predators could have deterred deer from my sites, which was another possible error of mine. And wildlife encounters at camera traps are variable, and a short study reduces the chance of finding the study animal. Sites could have been too close to human disturbances, so that could have been something I could improve on, since there could have been a lot of noise, scent, and etc. at the sites. My measurements could be wrong, so maybe my plants weren't the same from the start to end. There was also limitations of a time frame for my experiment. So if I were to do this again, I would take more time to collect my data. Hopefully, I would have gotten deer. Use an attractant and place sites in isolated areas instead. And I would like to thank Dr. Begley Miller, Dr. Rubo, my science teacher, Jacob Schofield, Miss Marguerite, who hosted me in her home, and Tessa students and Mike Tierney for all their help in conducting my research. Any questions? Yes?
Was the camera motion sensitive or was it
Yes.
on? Okay.
It was motion sensitive, so it wouldn't run out of battery too
Did you see
much.
any evidence that anything had eaten them on the leaves or anything like that?
There was no change in height or width throughout the entire thing. So even though in the video you saw the baby coyote was very close and sniffs my plants a lot, there was no evidence of it browsing on it. Any other? Yes?
You may have mentioned it, but can you identify what zoonotic
Disease?
meant, or what that is? Is that a disease or?
Zoonotic disease is a disease that comes from animals to humans.
Wow.
Any others? Yes?
Do the research methods require that you have your own plants in pots, or could you have had identified the plants in their natural habitat and just watched what happened? In other words, I don't know research methods, so I don't know whether you were forced to have plants in pots.
Yes, I understand. It was ideal to have the buckets for it to be the ideal height that study showed for where the plants are usually like to be eaten by deer. So that's why I used the buckets instead of just using the plants nearby, since most of them were not at that ideal height. And yet, yes?
Where did you find what the ideal height is?
There was a study shown in Penn State News where they conducted a very similar research, but there was actually deer. Any others? Okay.
Next up, we have David Mercado from Summers High School, and he's what they call a rising senior here.
Yes.
I've never heard that. That's awesome. So he's studying the relationship between invasive earthworms, leaf litter, and soil conditions.
So you may be wondering, why should we care about invasive earthworm species? Well, there is no current native earthworm species since the last glacial period, which was over 10,000 years ago. And what caused such a large amount of invasive earthworms was that they were brought over from Europe in the 1600s, and they would be used as bait. And when there were too many of them, they would just be dumped onto the ground, which would be what would cause a large amount of earthworms today. And in the past decade, jumping worms have been discovered more frequently, and this is the type of invasive species. And basically, jumping earthworms are different from other species of earthworms since they burrow in the top layer of the soil, and they usually take out a lot of soil nutrients that cause restricted root growth, and that's detrimental for slow-growing trees and plants as it causes them to die easier. Past studies have shown that there's a correlation with invasive earthworms and leaf litter disappearance, as well as more acidic soil. So the more abundance of earthworms there are, it basically turns a beautiful forest like this into a forest as you can see on your right, with less plant biomass and less leaf litter biomass. So my research question was, does the biomass and number of invasive earthworms change soil conditions and correlate to leaf litter disappearance? I had two hypotheses, and my first hypothesis was that if there is a larger biomass of earthworms, then there should be a change in soil conditions on the top and bottom layers of soil. And basically what I mean by that is there should be a change in things such as bulk density, which determines root growth, and organic matter. My second hypothesis was that a larger biomass and number of earthworms would correlate with less leaf litter, as this was shown in past literature, and I was expecting to find this in my study as well. So I basically went to 5 sites to collect soil samples, leaf litter, and earthworms, and here are my 4 sites: the Hidden Valley Trail, the Briarcliff Peekskill Trail, the Twin Lakes Trail, and the CH Trail. And each of these sites would have 5 different subsamples. So at each subsite, I would dig 6 inches of the soil using a soil core, and I would collect the top 3 and bottom 3 inches and find the pH of each one. And as you can see in the background of this picture, this is the pH meter, which is basically a probe you stick into the soil to find the pH. I would collect leaf litter by using an 8 by 10 inch frame, as you can see here, and I would put it into a bag to be weighed for biomass. And in this 8 by 10 inch frame, I would pour 1 gallon of mustard seed mixture, and the reason why it's mustard seed mixture is because earthworms are irritated by the contents in it, and it causes them to attract more to the surface. So I basically use that as bait, essentially. And I would collect earthworms in that frame. So my lab methods included finding the biomass of earthworms and leaf litter, and here you can see the weighing of the earthworms, and this one's trying to escape. He thinks he's sneaky. My next step would be sifting the soil to get rid of any little rocks and pebbles that were in my soil samples. And the reason why I did this is because I needed to heat up the soil at 221 degrees Fahrenheit to find bulk density, which basically the more bulk density the soil has, the less root growth plants are able to receive. Then I would find organic matter by heating up the soil samples 2 different times, one at 221 degrees Fahrenheit, and then I would weigh it, and then the second time at 600 degrees Fahrenheit. Unfortunately, the drying oven was only able to go to 450 degrees Fahrenheit, so that may be one source of error in my study. I would also use the loss on ignition and organic matter equation to find the percentage of organic matter. So here's my data. This first figure shows the earthworm biomass and leaf litter relationship, and as you can see here, as there's more leaf litter biomass, there's a general trend of more earthworm biomass, which is very interesting, since past studies have shown that more earthworm abundance leads to, it correlates with less leaf litter since they're eating it up. My second figure is the number of earthworms and leaf litter biomass. The difference between the number of earthworms and biomass is basically the weight for each subsample site. This one's just seeing if there's any correlation with the numbers in leaf litter biomass. And as you can see with the p-value, there wasn't a significant correlation, but there was still a general trend of more leaf litter biomass correlated with larger amounts of earthworms. My third figure shows the number of earthworms versus the topsoil pH. And as you can see here, the soil pH ranges from 4 to 6 usually have the largest cluster of earthworms. And this also contradicts past literature, as past literature was able to find that invasive earthworms cause the soil to be more acidic. So biomass and number of worms had no correlation with the organic matter or bulk density. So as I mentioned earlier, I found the organic matter and bulk density of the soil, but it had no correlation with the top or bottom layer. And I'd also like to mention that biomass and number of worms had no correlation with any soil qualities of the top 3 inches. So that's why you saw no graphs of the bottom pH. And the data showed that the larger the biomass of earthworms, the more leaf litter biomass, as I mentioned, contrary to past studies. And pH in the range of about 4 to 6 had large numbers of earthworms. So my future research would include testing other forest sites to see if there's any correlation between earthworms, soil conditions, and leaf litter, and to see if there's also this strange correlation that I found here in Teatown. So my take-home messages are that my findings contradict past studies, as you saw, and I'm able to conclude that Teatown likely doesn't have an issue with overabundant invasive earthworms at the sites I tested, as you can see with the large amounts of leaf litter and the not as acidic soil. I'd like to acknowledge Dr. Begley-Miller, Dr. Rubo, all the TESA students, my family, my research teacher, Mr. Malia, and Mr. Schofield. Any questions? Yes.
You mentioned the jumping earthworm, but are all the earthworms like equally detrimental?
They're not as equally detrimental. It's just jumping earthworms that have been found more recently that have been shown to have been detrimental. I just want to see if there was a correlation in general. And I also wanted to mention I didn't find any jumping earthworms at any of my sites, and most of them were common earthworms. Any other questions? Oh yes. Well, they have a darker brown appearance, and usually when you dig them up, they start to they wiggle very violently, apparently. So that's how you could tell the difference.
So if you encounter one in your garden, should you get rid of it?
Most likely. Any questions?
I do have another.
Yes.
Growing up, we were taught that earthworms were good for the soil. I don't know if anybody else was taught that.
Yeah.
So now, when did we discover that they're really bad? Do you know?
Yeah.
Do we know when we?
Would you like me to answer that?
Sure.
So earthworms in forest systems are not good because they break up that leaf litter. But in your garden, they're great because they break up that leaf litter. So that's what keeps all.
Yeah.
So it depends on where they are. That's the answer. Yeah.
All All right.
Ready? So we got through our first 5 speakers. Pretty good so far, right?
Yeah.
All right. So our next speaker is Patel, who's also he goes to J.P. Stevens High School, which is New Jersey. So test is expanding, right? We're gonna go tri-state. We need Connecticut next year. Although he's not the furthest. We've had a student from Hong Kong, so it's pretty hard to beat. But Dev is going to talk to us about his project titled "Humans versus Biodiversity: The Influence of Recreational Hiking on Animals." Get away, Dev.
So humans have been destroying habitats for many years, as habitat destruction, hunting of predators, and human disturbances all lead to decline in predator species. A decline in predator species leads to increase in mesoconsumer species such as deer. Deers are eating the understories of forests and causing them to lose their plant density. That overall leads to the destruction of ecosystems and food chains. So many large predators have been driven away by humans. The goal for my project is to see how humans affect biodiversity here at Teatown. My first research question and hypothesis. My first research question is, how do human disturbances, noise, habitat fragmentation, and recreational hiking affect the presence of mesocarnivores in certain areas? My first hypothesis is, if there's an area with more humans present, then predators are less likely to appear there. My second hypothesis is, if more humans are present in an area, then prey are more likely to appear there. My second research question is, how does predator lure, which is grounded animal glands put together to attract certain animals to certain areas, affect the behavior of mesocarnivores? Does it cause them to leave their comfort zones and force them to move closer to areas with more humans? My hypothesis is, if lure is used, then predators within a close proximity will be attracted toward the cameras I have set up. My study design. My project is both experimental and observational. It is observational when I'm not working with lure, as I'm not altering or changing anything. It becomes experimental when I am working with lure, as I'm changing the presence of animals, causing them to come towards my cameras. The independent variables for me are trail usage and distance from trail. My dependent variable is presence of animals. I have 12 cameras, which all look like that. There are 6 split between 3 high-use trails and 6 split between 3 low-use trails. Each trail has one camera 10 meters from the trail and another camera 50 meters from the trail. Here is a Google Earth map of where all my cameras are located. My 3 high-use trails are right here, and they're all very close to lakes such as Teatown Lake and Vernay Lake, and they're in heavily trafficked areas by humans. My 3 low-use trails are on the outskirts of the map. Here is a Teatown hiking trail map. The blue circles indicate low-use trails, which are located here, here, and here. And the red circles indicate high-use trails, which are these 3. My methods. So the data I am collecting is hiker count, which is the number of hikers on a trail in the period of an hour. The usage of lure, whether lure was used to attract any animals towards my cameras. Date, time, and temperature. This includes the day the animal was captured on camera, what specific time it was captured, and how warm it was in degrees Fahrenheit. The trail usage, and distance from trail. This includes the name of the trail, the usage of the trail, whether it's low or high, and how far the camera was from the trail, 10 meters or 50 meters. An example would be the Overlook Trail, and the camera would be 10 meters as it's a low-use trail. Animal species. This includes what type of animal it is and what role it plays in the food chain. For example, a coyote, and that's a predator. My result. Figure 1, which is hiker count per trail in an hour. The x-axis shows all the trails and their usage. The y-axis shows the hikers per trail. For my 3 low-use trails, there were no hikers, but for my high-use trails, there was 5, 7, and 30. Figure 2, events per day with the usage of lure. For an event is in a period of 30 minutes if there's an animal that passes by. That is one event. For no lure, I had 2 events per day. With lure, I had 1.2 events per day. I calculated this by combining the total number of events divided by the number of days that I had lure or no lure. Results. So figure 3 is the total number of events at high and low use trails. On the x-axis, I have my trails and usage once again. On my y-axis, I have number of events. The light blue represents 10 meters from the trail, and the dark blue represents 50 meters from the trail. From this data table, you can see that many prey were closer to high use trails, and they were only 10 meters from the trail. This is a chart that shows all my trails and the species I observed at that. For the Brierside Peakscliff Trail, the Cliffdale Teatown Trail, the Overlook Trail, and the first Hilltop Trail, I only saw white-tailed deer. For my second Hilltop Trail, I saw white-tailed deer and mourning doves. For my Twin Lakes Trail, I saw white-tailed deer and squirrels. Here are images of my findings. So this is a deer which I saw at the Overlook Trail. It was 10 meters from the trail. This is the second hilltop trail. I saw this 10 meters from the trail. This is another hilltop trail. It's the first one, and it was 50 meters from the trail. All three of these are deer. This is a squirrel. It's pretty hard to see, but it's in the nighttime, and it's at the Twin Lakes Trail. This is another squirrel at the Twin Lakes Trail, and both of these show mourning doves, which were at the second hilltop trail. My discussion/conclusions. So I used lure for 6 days, and I didn't use lure for 6 days. The overall results show that the predator lure had no effect on the experiment, as my hypothesis was negated. It is likely that the animals were not in a close enough range for the lure to take effect. As a result, I combined all my data, not including lure. All the data collected were prey items. Prey items were more abundant on high-use trails, supporting my hypothesis. My take-home message is, prey were more common in areas with the higher usage by humans. Sources of errors could be, this project was designed for a longer period of time, as time was a limitation. The animals were not in a close proximity for the lure to take effect and work. And the hiker counts were not taken at the same time every day with similar weather conditions. In the future, if I were to conduct this experiment again, I would make sure that I would have more time to obtain more data and create a more in-depth analysis. I would also make sure my hiker counts were at the same time with similar weather conditions. I'd like to acknowledge Dr. Rubo, Dr. Begley Miller, Mike Tierney, all my fellow test students, and my parents. Thank you. Is there any questions? Yes, Priya.
How come you showed so many deer in your photograph, whereas this other didn't have any?
Because all I got was deers, and I couldn't find predators, even though I put out a predator lure, which is strange, but I got what I got.
Area?
They were the deer. The cameras, I don't know if they're in the same general area, but my cameras only got deers and other small prey items, and her cameras got predators. So,
Exact similar location. So it's just like that's science. That's what happens.
yes, Priya.
So if you had like prey like deer, wouldn't that attract predators?
Not necessarily. I mean, they were seen during the day, and other predators like foxes and coyotes are diurnal, which means they appear during dawn and dusk, and deer don't really appear during that time.
So where are the predators during the day?
I don't know. I didn't get them on my camera. Is there any other questions?
All right. Thank you, Dad. Our next speaker is Alana Rabinowitz, who is a rising senior at Mahopac High School, whose title is Testing Whether Benthic Macroinvertebrates Are Bioindicators of Microplastics.
So what are benthic freshwater macroinvertebrates? You guys probably don't know what these are. Benthic just means that the organisms live at the total layer, like the bottom layer of the water or the stream. Freshwater macroinvertebrates are organisms that are spineless, and you're able to see them with the naked eye. They live in lakes, rivers, and streams, not in the ocean, the ones that I'm testing. Microplastics are plastics that are small fragmented plastics that are less than 5 millimeters in diameter. And they are separated into two different categories, primary and secondary microplastics. Primary, which I will be using in my experiment, they are microplastics that are actually made to be this small in consumer products, like in the typical bean bags or your neck pillows. However, secondary microplastics are plastics that are broken down from larger pieces of plastic, like your typical plastic bag, which become this small by fragmentation. So why does this matter? Well, as you all know, humans are pretty bad at throwing away their trash. They litter, and this litter often ends up in large bodies of water, like streams or lakes or the ocean. This then gets broken down into smaller pieces, like I mentioned before, into microplastics. Microplastics are often mistaken for food by small aquatic organisms because of their appearance, their size, and their color. So in this case, a macroinvertebrate could eat the microplastics. Macroinvertebrates are typically eaten by fish. So the microplastics can actually be transferred to the fish. Actually, then the microplastics can then be transferred to other larger predatory animals like bears and ducks, which consume the fish. Now the microplastics have entered the bear and the duck. Microplastics are known to be endocrine disruptive, which actually when are known to have adverse effects when organisms consume them in the food chain. And maybe you forgot, but we are also too in the food chain. So instead, the fish is killed for our human consumption. The microplastics are now in our system. So, like I said before, you probably are wondering, well, what does endocrine disruptive really mean? It basically means that past a certain dosage, it will cause an imbalance in our hormonal system. This will then cause cancerous tumors to grow, birth defects, or other hormonal disruptions. My hypothesis is if macroinvertebrates ingest or respond to the microplastics, then they would be a bioindicator of microplastics. So my methodology. I selected 2 sites from the Bailey Brook River, the upper and the lower, in the Teatown reservations. I then collected 36 liters of water from the upper site, and I then collected the macroinvertebrates and the sediments at both sites. I then identified the species of macros and separated the macros into their levels of sensitivity and to pollution. I collected 3 types: the aquatic worm, which is known to be tolerant to pollution, the dragonfly nymph, which is semi-tolerant to pollution, and the hellgrammite, which is sensitive to pollution. You're probably wondering, well, what does this really mean? Well, this just means that this is their tolerance to pollution. The presence or lack of these certain macroinvertebrates could tell someone if the water is heavily polluted or lack thereof. I then repeated each level 2 times with one macro per container. So there are 36 containers in total and 36 macros in total. I then added plastic pellets, the primary microplastics like I mentioned before, in each container. There are different amounts. I separate into low, mid, high to see if the amount of microplastic would affect the macros differently. I then transferred each species into a container. I aerated the containers and rotated the filters every few hours. This is because we didn't have enough filters to aerate every single container, so I had to rotate them in order to make sure that they all had a constant oxygen level. I recorded DO, which is dissolved oxygen. This basically just means how many oxygen molecules are in the water sample. pH and temperature. I measured these every day. I then recorded the visible health signs of macros, basically to see if they're lethargic, if they're moving, or if they're moving a lot. So basically, what this shows you is that most of all my macros basically survived. However, there is one of the dragonfly nymph that was in a control that died. So there was no microplastics and it died. So this could be due to previous sickness or an injury due to transportation. So this is the DO, which is the dissolved oxygen, basically to see how many particles of oxygen molecules are in the water sample per treatment for aquatic worm, dragonfly nymphs, and hellgrammites. As you can see through these graphs, they basically show a constant decrease, and you can see that the variability is quite large, as well as the error bars. This is due to the fact that I mentioned before how there's not enough filters and there is a lack of them. So me constantly doing the rotations isn't good enough. Probably having more filters would be better. The discussion. So basically what I found is that there's insufficient evidence of macros becoming bioindicators of microplastics. So what happened? So there's a lot of limitations. For example, the duration of time. As some of you may know, TESA is only 4 weeks. The first 2 to 3 weeks were spent looking for sites, collecting macros, and getting equipment. I officially actually started my experiment on the first day of the 3rd week. I then did a cutoff point on the first day of the 4th week. So I actually only observed them for about a week, not enough time. I plan to do, and I will continue to do, this research for 3 to 4 months. This will show more conclusive results with enough time. The lack of equipment, like I mentioned before, is a big problem. So, as you could see, this is taken from the past graph. It's a dragonfly nymph DO. Like I said before, a lot of variability, constant decrease in oxygen levels, which is not good. We want to keep them not lethargic, high with oxygen levels, so they don't die because of it. We want to just see how the microplastics affect the macros, we don't want any variability with any other factors. So an ideal situation would be to have every container having a filter. So me not having to filter it every few hours, not to have a lot of variability. Although you can still see some variability, there will always be variability. However, you can see it's more constant and less error. So for the expected results, after continuation of my experiment for the next 3 to 4 months, I should be able to see if the benthic freshwater macroinvertebrates is a good indicator of microplastics in the environment. Whether that would show positive, negative, or no correlation, we need to have time and we need to have proper equipment. I would like to thank Dr. Rubo, Dr. Bedley Miller as my mentors, Ms. Stevens as my science research teacher, Tessa's students. Special thanks to Saya, Olivia, and Christian as my friends and helpers along the way, and my mom for semi-supporting me. Thank you.
Olivia Ng, and she's a returning Tessa student. She was here last year, she decided to come back. And so this is a project that expands on her project from last year, and it's multiple stressors and their effect on beaver stunt mortality. She's from Westlake High School.
So for some background information, the population of beavers had been relatively steady over the years until the 17th century, where they were practically hunted to extinction due to the fur trade. However, due to recent conservation efforts in the 1900s, the beaver population has exploded, which is why there hasn't been a lot of research on how beavers affect the local environment, especially in suburban areas where they have moved in. So this is really important because beavers are obviously known to feed on tree bark as well as take down a lot of trees for dams in their own habitats, leaving behind beaver stumps. Now typically this wouldn't be a huge problem because beaver stumps will naturally regenerate over time. However, beavers do increase, however they could be they make them more susceptible to stress factors such as bugs eating on the leaves, deer, herbivores, since it's already safe for that there's an abundance of white-tailed deer in the area, as well as just fungi increasing stress, decreasing the likelihood of a tree regenerating, which could lead to deforestation over time. So that's why my research question was, how does stress affect the mortality rates of beaver stumps? And I hypothesized that stress factors like bugs eating on the leaves, deer herbivory, and fungi will increase the mortality of beaver stumps. So I conducted my research basically along the lakeside trail where beavers have taken up residence, as well as a portion of Renee Lake that can walk along the Twin Lakes loops. And so this is just basically a sample of my Excel sheet where I collected data on if the tree was chewed to, and for comparison I also collected data on unchewed within the same species for comparison, if there's evidence of deer browsing as well as bug damage, and if there's presence of fungi, as well as if the tree was alive or dead, and the location. So looking at this first graph, we see basically a proportion of alive and dead trees for chewed and undamaged trees. And as you can see, it's about 50-50 for chewed in comparison to undamaged, where very little of the trees were dead. So basically supporting that chewed trees are more likely to die. Now in terms of, and as you can see, looking at the different types of stressors with the presence, basically just number that are alive with these stressors between chewed and unchewed. And you can see that for chewed, there was a greater amount of stressors, with fungi actually showing no stressors, since I found fungi only appeared on trees after they died, basically meaning that they didn't actually increase the amount of stress on any of the beaver stumps or any unchewed trees. And then this is basically going against my hypothesis, since you can see as the number of stressors increase, beavers, there was basically no beaver stumps really alive or dead. There's a lot of beaver stumps actually died with just zero stressors at all. So there was really no correlation. And then these are like the 4 main species that I found, and you can see that between alive and dead, there's basically a 50-50 ratio. So for my discussion, like I said earlier, fungi appeared on trees after they die, which means that they didn't really increase the amount of stress on the trees. From my research last year, I found that deer tend to not eat the regenerating saplings because they're often very difficult to access. They're on really difficult terrain and because of presence of humans hiking along a lot of the trails, they could have deterred a lot of deer from eating on the beaver stumps. So that's kind of one of my limitations, as well as the fact that there's plenty of food elsewhere around Teatown. And then even though that bugs were the most common stressor, it still only damaged a small proportion of the trees. So if we looked at, going back to the graph, you can see that they only chewed about 50 for chew, which is out of 320 of my sample, so it's a relatively small proportion. So as I said earlier, many beaver stumps died without any stressor, and that could be that a lot of the beavers fed on a lot of older trees, which are less likely to regenerate to begin with, as well as there could be other factors that could have changed my results depending on the type of species. I know I was doing some research, and trees that age more slowly, like maple and oak, are less likely to regenerate, as well as just general growing conditions. And this is really important because presence beaver could lead to deforestation over time. And this is really important, especially in suburban areas, since it leaves a lot of sunlight to reach the ground, which could increase the amount of invasive species. So in conclusion, my data did not support my hypothesis, as I found no correlation between beaver stump mortality and stressors. And like I said earlier, for future research, I would like to look at other conditions that could have affected beaver stump regrowth, such as soil acidity, sunlight, weather, etc. And like I said, for limitations, hikers could have potentially scared away some of the deer from eating on the regenerating beaver stumps, as well as just human error in identifying trees and maybe some of the deer herbivory. And then I would like to thank Danielle, Mike, and my fellow TESA students, especially Priya, Alana, and Saya, Mr. McIntyre, my science research teacher, and my family for helping and supporting me. Any questions?
When you indicated that your hypothesis didn't pan out, I'm reminded that unfortunately Marguerite Pitts had to leave, I believe, but her wonderful late husband said that's research, that you learned something and that it didn't work out. And there are many times where it doesn't work out, and then there are occasionally times where it does work out. So that was very good. Thank you.
Thank you.
All right, so our next speaker is Sayako Iseki Nevins, who goes to Sleepy Hollow High School. And Sai is going to talk to us about, I'm not going to try to pronounce it, but I'm going to say E. coli and coliform bacteria colonization of microplastics. I'll let you pronounce it. You're better at it than me.
Okay, so we're all humans, and we produce tons of plastic waste daily. And this plastic waste can take in many different forms, such as plastic bags, plastic bottles, or tiny pieces of microplastic. And microplastics are smaller than 0.5 centimeter in size. And because they're so tiny, they're ubiquitous in many aquatic habitats. So once these tiny pieces of plastic are in aquatic habitats, they're exposed to the many different types of bacteria. And plastic is known as an ideal surface for bacteria colonization because plastics don't naturally degrade in aquatic environments. And so once these different types of bacteria attach to the microplastics, some of which could be harmful for the environment, the microplastics are able to transport these bacteria to new areas within the water bodies or even within the bodies of aquatic organisms. And once again, this chain returns to the humans as humans are again exposed to water bodies and aquatic organisms. So humans are gaining exposure to these potentially harmful forms of bacteria because microplastics transport them. So the major water body that we live near is the Hudson River. And unfortunately, the Hudson River has experienced a lot of pollution, especially before the 1960s when toxic sewage discharge was unregulated in the Hudson. And even though there have been many cleaning efforts in the Hudson, 2 major pollutants still persist, one of which is coliform bacteria. Coliform bacteria takes many forms. One form that we're familiar with is E. coli. And E. coli is a gut bacteria that's found in humans and mammals. And it's perfectly healthy once within the body, but once excreted, it can cause very harmful illnesses. Another type of pollutant in the Hudson is microplastic. And as I said, microplastic are tiny pieces of plastic, and microplastics are a relatively new area of study, so not a lot of research has been done. So both of these pollutants, coliform bacteria like E. coli and microplastics, have been identified as pollutants of the Hudson, but the interaction between these pollutants has not been studied specifically in this area. Because of this gap in knowledge, my question was, are E. coli or coliform bacteria able to colonize microplastics in the Hudson River? I hypothesized that if I placed microplastics in a Hudson River water sample that contained these types of bacteria, then these bacteria would attach to the microplastics. My second question was, does incubation time, meaning the amount of time the microplastics are in the Hudson River water sample, affect the number of bacterial colonies I see? So previous literature has determined that the typical window, the minimum amount of time needed for bacteria to attach to microplastics, is 2 weeks. So I hypothesize that if microplastics are incubated in this water for 2 weeks, then I will see more colonies than I would once I test at 1 week. So initially, I had to collect a water sample of the Hudson that I suspected would contain E. coli and other coliform bacteria. To determine the site, I looked at the Riverkeeper website, which has a map of bacteria areas of concern in the Hudson. And so one area of concern was Vanderdonk Park, which is a Sawmill River location in Yonkers, New York. And this river flows directly into the Hudson and has been reported to contain very high levels of Enterococcus, which is a gut bacteria associated with E. coli. So I collected a 4-gallon water sample, and I brought it back to the lab for testing. So as you can see here, this is a mixture of bacterial testing gel and the water sample I collected. I let it sit for 48 hours, and the different colored dots represent different types of bacteria. In blue, I've highlighted a few of the E. coli colonies I found, so I was able to confirm that E. coli was in this Hudson River water sample. In red, I've highlighted a few of the other fecal coliforms, other fecal bacteria present, and in green is an unidentified form of bacteria. Because I was able to determine that this sample of water did contain coliform bacteria as well as E. coli, I know I was able to use it for my experiment. Initially, I sterilized all my equipment to minimize any sort of bacterial contamination, and I created my first group. So my first group was a negative control, and this functions differently than other controls because this is essentially a check to make sure that none of my samples experience any sort of bacterial contamination. In my control, I used sterilized water, which for the purpose of my experiment was boiled water with sterilized microplastics. My second group was my experimental group, where I placed the Hudson River water that contained coliform bacteria, as well as E. coli, with sterilized microplastics. And you'll see that I've separated each group into 2 subgroups, 1 week and 2 weeks. And the 1 week group I would test after 1 week, and the 2 week group I test after 2 weeks for bacteria. So after 1 week, I tested my first group of microplastics. And in my negative control, as you can see, there are no colored dots, meaning that I did not find any sort of bacterial contamination. In my experimental, I've highlighted the coliform bacteria that I found, meaning that coliform bacteria, fecal indicating bacteria, were able to attach to microplastics, even after 1 week, which isn't even the full scope of my study. This graph is demonstrating the difference in bacterial concentrations in my control and experimental. And you can see that the one type of bacteria that I found was coliform bacteria attaching to microplastics in my Hudson River water sample. And you'll also notice that the error bar right here is fairly large, but that's due to the fact that bacterial levels can vary very greatly in natural environments. And this graph is demonstrating the difference in concentrations of bacteria in the Hudson, which is represented in blue, and the orange, which is my experimental microplastic group. So from this we can see that coliform bacteria are naturally much more abundant in the Hudson than E. coli, which is one reason why I may not have seen any E. coli on my samples thus far. So from these preliminary results of my experiment, we can deduce that fecal bacteria are able to attach to these tiny pieces of plastic that are extremely abundant in all water bodies, including the Hudson. And we're gaining exposure to these pieces of plastic in the food we eat as well as the beaches that we play in. So this should raise a level of concern for all these different types of pollutants in the Hudson. After Tessa, I'm going to continue this project because I still have one more week of data to collect, and I'm going to continue to examine E. coli and coliform bacteria colonization on microplastics, as well as the effective incubation time, 1 week versus 2 weeks, on the number of colonies I see. After this research is completed, I'd like to examine the transport of microplastics and the coliform bacteria attached to them in the Hudson River, as well as the efficacy of different microplastic removal methods in order to eliminate this pollutant. I'd like to thank Dr. Begley-Miller and Dr. Rubo, Ms. Zielinski and Mr. Ehrenberg, all the Tessa students, especially Olivia and Alana for helping me transport stuff, and Alicia and David for all the laughs. My family and everybody, thank you for their support and guidance. Question?
Okay, so I think it was on slide 7 or 8, but for the negative control. So
yes.
If you did find, no, you're going to.
Oh.
Yeah, keep going. Yeah, that. Okay, so if you did find coliform,
yes.
negative control, what would you have done?
I would have had to conduct my experiment again, because if I already had coliform bacteria in a sample where there wasn't any Hudson River water sample, then that would mean that I had some sort of bacterial contamination, and I couldn't say that these results were valid.
Excellent. Thank you. What is that health effect? Are you saying that if the bacteria is on the microplastics and then the microplastics arrive in us and the animal life, are you saying it's conducting disease?
Yes.
Yes.
That's one way that microplastics are harmful. Another way is that bacteria naturally break down in the environment, but because microplastics don't break down, they're facilitating these certain bacteria to persist longer than they naturally would. So we could have more coliform bacteria in the Hudson solely due to the fact that microplastics are existing. Yes.
Are there any beneficial bacteria that are breaking down microplastics?
Well, one type of bacteria that is found to be associated with microplastics are polycyclic aromatic hydrocarbon degrading bacteria, which are bacteria that are known to degrade plastic. So that's one area of research that hasn't really been studied, but could possibly be beneficial, so yes.
Has the research been studied in the seawater?
Yes, so studies have found, the reason why I conducted this research is because studies have found that E. coli is associated with microplastics in seawater environments. But because the Hudson River is an estuary and it's very unique in itself, I thought I'd conduct the research locally.
So our last speaker is Annika Rust from Croton Harmon High School, and she's an incoming junior. And her project is Surviving the Drought, comparing resilience between native and invasive species.
So starting around the 16th century was the beginning of transatlantic exchange, and so this is when a bunch of crops and goods were being exchanged across the globe, and so this introduced invasive species. And invasive species have no natural predators in their new environments, and so this causes them to be very aggressive growers and wipe out native populations. So this leads to an overall lack in biodiversity, and so some effects of this are a decline in overall ecosystem health and a lack of natural resources. So when formalizing my experiment, I was also looking into global warming. And so with global warming, they're predicting an increase in both the intensity and frequency of droughts and floods in the near future. So this led me to my gap in research. How will these new expected conditions affect both native and invasive plant populations? So this is my question. Are invasive plants more resilient to drought conditions than native plants? So what I did was I found two comparable plants. One was native and one was invasive, and they're comparable because they're in the same family. And then I conducted drought conditions across both of them and saw who was more resilient. So for my experiment, I had 2 separate parts, and that's why I have 2 different hypotheses. So for my first hypothesis, I was reading a lot of literature, and one indicator that I found that indicated a higher rate of resilience was a higher RWC. And this just means the relative water content of the plant. So the higher the relative water content of the plant, the more resilient it should be. So I hypothesized my invasive plant species would have a higher RWC than my native plant species. And so this led me to my second hypothesis. If my first hypothesis proved true, then this should also show that my invasive species will exhibit a higher rate of resilience when drought conditions are created on both invasive and native plants. So for my first experiment was finding the RWC, and what I did was I found 6 different plant species, and so there were 3 pairings of native to non-native. So I have a native and a non-native, a native and a non-native, and a native and a non-native. So what I did was I collected 4 leaves per plant, and I got the fresh weight of each of those leaves. Then I saturated each leaf in water for 4 hours in a dark cabinet, and then I calculated the turgid weight for that leaf, and that's just the fully saturated weight of the leaf. Then I dried each leaf for 24 hours in a drying oven at 80 degrees Celsius, and then I got the dry weight. Then I took all of these different weights and I plugged them into the RWC formula, and I got the following results. So you'll see that I have my native to invasive pairings on this graph. And so for my first pairing, my data was statistically insignificant because my error bars overlap. However, for my second 2 pairings, there was statistically significant data. So as indicated in the green bars, my invasive species had a higher RWC than my native species, and this supports the hypothesis that I originally made. The RWC was higher in the invasive species. So then this led me to the second part of my experiment, which was my drought experiment. So because I saw a higher RWC in my invasive species than my native species, I thought that my invasive plants would also exhibit a higher rate of resilience when I introduced drought conditions. So while I was measuring those things, I was controlling the soil, the sunlight, and the location. So I obtained all my plants from Teatown, and they were all located under the same covered tent throughout the entire experiment. So what I did was I collected 18 plants. 9 of them were native, and they were the jump seed, and then 9 were invasive, the oriental lady's thumb, and they were part of the same family, so they were comparable to each other. Then I further separated them into 3 groups. So I have a control group, and then 2 experimental groups. So for my control group, I watered them throughout my entire experiment, and then for my first experimental group, which is my immediate group, I introduced drought conditions, so I didn't water them at all until I saw the first signs of drought stress, and that's when I started watering them. And then for my 4-day, I waited 4 days after the initial first signs of drought stress to start watering them to test their threshold to see if they were able to respond to water after 4 days of experiencing drought stress. So this is an example of what my data table would look like when I was collecting my data. So I collected data about the width of the plant, the height of the plant, the droop distance, and the number of leaves for each plant every day, and I collected my data at the same time to eliminate any external variables. So the first result that I found was height, and so what I found was that height was really not statistically significant, and so across my native and invasives, generally throughout, if you look on the x-axis, days 1 through 12 are listed, and then there's a gap for 9 and 10 because I was unable to collect data for those 2 days. And then my plant height on my y-axis in centimeters. And you'll notice that across the whole time, the plants maintained relatively the same heights, and any variation was not due to the experiment I was conducting. The second piece of data I collected was leaf number, and again, my data was not statistically significant. And you'll look on my x-axis, again, I have the days, but this time on my y-axis, I have the number of leaves. And again, if you just follow any one of these lines, they maintain relatively the same number of leaves. The next piece of data I was able to collect was droop distance, and so this was the first statistically significant data I obtained. But initially, when I was just looking at comparing invasive to natives, I found no statistically significant data. But when I combined those 2 groups and compared them to time, I was able to find statistically significant data. So as you'll notice, the droop distance increases throughout time. But one interesting point to note out is that on day 7, the droop distance actually decreased. And this was due to an external factor that I didn't really account for, which was a rainstorm that happened on the night of day 6. And so this caused a lot of moisture in the air to happen on day 7, which caused the plants to perk back up and their droop distance to decrease. And then the last piece of data I was able to collect was on plant width, and this data was statistically significant. So on my x-axis I have the days, and on my y-axis I have the plant width. And so you'll notice that my natives and my invasives all start out at generally the same area. But if we take a look at the red line, which is one of my invasive plants, they maintain basically the same amount of width throughout the whole time. But then if you take a look at, let's say, my native green line, you'll notice that it decreases a lot, and this is because as the native plants were wilting, their width was decreasing. And so discussion. So a lot of my data was statistically insignificant, which was very unfortunate, but I was able to use a lot of visual observation and cues to support my hypothesis. So as you'll note, this is my native species, and you can see a lot of leaf browning and leaf wilting, whereas in my invasive species, you'll see neither of those. And so that indicates to me that the invasive species was in fact more resilient than my native species. So this will indicate that some invasive plants are likely more resilient to droughts. And additionally, invasive plants may be better able to withstand these predicted conditions of the future with increased frequency and intensity of droughts. So some sources of error, like I mentioned earlier, were the humidity and weather, which caused for some variation in my droop distance. Additionally, human error, something could be off with my measurements. And then also the short time span played a big factor. I was only able to conduct one trial, and additionally my experiment was incomplete because I was only able to start watering my native group because my invasive group actually never exhibited enough signs of stress for me to start watering them. But that also supports my original hypothesis that yes, they were more resilient. So for some future research, I would like to use other native to invasive pairings to see if they react in the same way that the plants I used did. Additionally, I would like to create more subgroupings to test resilience threshold. So I had my 4-day group to see if they were able to respond to water after 4 days of exhibiting drought stress, but I would like to add maybe like a 7-day to see if they could respond after that long. And then additionally, I would like to add in other drought conditions to make the drought more realistic, such as increased sunlight and drier air conditions. And then a special thanks to my mentors, Dr. Danielle Begley-Miller and Dr. Michael Rubo, all the TESA students, my science research teacher, and my parents. Any questions? Questions? Yes.
So why did you choose to put the plants outside instead of inside?
I'm not really sure. I think it was just lack of space maybe, and also we had the covered tables readily available. So that was nice. Any other questions? No? Okay. Thank you.
I want to thank everybody for coming. It's really nice to see this much support for our students. They worked really hard over the last 4 weeks, and they've been a pleasure to work with.